Hello and welcome to Multiframe Webinar 1 Video 5 on working with structural geometry. We've seen how we can modify the structure interactively and graphically. Now let's see how we can make the modifications numerically. We have lots of different functions for making numerical modifications. We can add a node by numerical coordinates just by typing in x, y, z. We can also double click on any node to modify those coordinates. In a similar way, we can double click on any member and modify the length and the slope. You should note that the slope is relative to the xy horizontal plane, so it's the true angle between the member and that horizontal plane. When you're changing the length of a member, normally node 1 is held fixed and node 2 is allowed to move, but there's a reverse member ends command to allow you to fix node 2 and then have node 1 move. If you want to modify the nodal coordinates, it's also possible to do that in the data window where we have an Excel compatible spreadsheet of nodal coordinates. There's also an additional spreadsheet of element lengths and slopes in that same window where we can modify length and slope numerically. Both of those tables can be copied both to and from Excel for transforming the model in Excel, and for advanced users it's even possible to extend the engagement with Excel to include complete generation of structural geometry using macros using the Multiframe automation interface. I recommend you take a look at the link shown below to see the automation samples that show how you can generate structures by using Excel. Let's move over to Multiframe and take a look at these numerical modification commands in action. If we start out with just a basic frame, then we can double click on any joint and modify the coordinates of that joint, so we can change the height of that joint to interact numerically. If we use the symbol command to turn on the numbers of the nodes in the structure, then we can see our frame window and our data window side by side, and you can see how our coordinates from the geometry are shown in Excel compatible format, and we can make changes in a similar way. The next tab over is the member geometry tab, and that allows us to change the length of different parts of the model. We can also do that interactively, so we can double click on a member and change its length there. But normally node 1 is held constant and node 2 will move. So if I want to move it in the other direction, then I need to reverse the ends of my member. So let's say I made a copy of this member and moved it down there to make an eave, and I want to shorten that eave. Then if I show my member coordinates, we can see that the local coordinate system runs from left to right. But if I select that member and from the advanced command in the geometry menu I reverse that, we can see we can make the local member axis run in the opposite direction. Now when I double click on that member and I change its length to 1 meter, then my right hand node is held fixed and my left hand node is the one to move, and we get the desired length of member that we want. If I want to change my model interactively using Excel, then I can start out with a new structure and I can generate a continuous beam. So I'm going to use the generate command, make a continuous beam, and I'm going to make it 20 1-meter segments to give me a starting point for my model. And then I'm going to turn this continuous beam into a catenary cable. So I'm going to remove my restraints off that beam. I'm going to go to my data window and I'm going to copy and paste my XYZ coordinates from that window. I'm going to switch over to Excel and I'm going to paste my X coordinates into Excel. So if I select the start of my column and I choose paste, then in the right hand part of the column you can see I've got a formula here which calculates the sag of the cable relative to my X coordinates. So I can specify here the amount of sag that I've got on my table and see how my Excel calculations update. Then I can select my Y coordinates inside Excel. I can copy them. I can go back to Excel from Excel to Multiframe and paste those coordinates into the Y column, and I can see I'm automatically generating my cable geometry. We can even create more advanced geometry than just a cable. We could start out by generating a grillage structure. So I'm going to use the generate command, generate a grillage, and I'm going to specify a 20 by 20 grillage. And then I'm going to set the origin of my grillage. So I'll go to a plan view, select everything in the grillage, find the center of my grillage, and just move that over to the origin. So I've got my origin at the center. And then I'm going to select my coordinates. So I'm going to select my XYZ coordinates, copy them, switch over to Excel, and I've got a spreadsheet set up here where I can paste in my existing coordinates, and then I can calculate the transformed coordinates. And I've put in the formula here for a hyperbolic paraboloid. That's kind of a saddle-shaped roof. That's an x squared z squared equation for the height of the roof. So I select the height coordinates, which is the transformed y coordinates. I copy those, go back to multiframe, select the y column, and then paste them into place. And you can see that hyperbolic paraboloid geometry is automatically created for us. So you can see there's lots of different ways to automatically create geometry numerically in multiframe. Thank you for watching.